Hey everyone, so we're going to do the 9.6 vectors in space. So we're just going to take what we learned in 9.4 and 9.5 with two variable vectors, the I and j, and do it with three variables, I, j, and k. But we're doing the same stuff, same process, just now with three. So the first thing that we did add is this distance formula, but same distance formula as with 2 points, just you're adding in that z here. But same thing, so let's do this 1 between the distance points of P1 and P2. And then we can label all these, so x1, y1, z1, x2, y2, z2. And then we can plug into the formula. So d equals the square root, and I'm going to draw that in last because I want to fit everything underneath it. So 4 minus -1 squared plus -2 minus 3 squared, it's supposed to be 2, plus 5 minus 2 squared, all under the square root. So 4 minus -1 is 4 plus 1, which is 5, and 5 squared is 25. -2 minus 3 is -2 plus -3, which is -5. -5 squared is 25. And then 5 minus 2 is 3, and 3 squared is 9. So 25 plus 25 is 50, plus 9 equals the square root of 59. So D equals the square root of 59. That's it. So now we're going to do the position vector, a vector whose initial point is at the origin. Find the position of the vector P1, P2. So this is that first thing we did of combining the i's together, combining the j's together, combining the k's together. So here we have vector v, is what we're trying to find, equals 4 plus -1 I plus 6 minus 2. These are supposed to be minuses. So 4 minus -1, and then 6 minus 2j, and then 2 minus 3k. So 4 minus -1 is 5, so 5i. 6 minus 2 is 4, so plus 4j. And then 2 minus 3 is -1, so minus k. Alright. Next, we will be doing the finding like v plus w, v minus w. Again, applying those same rules from before, just now with three variables. So let's start with v plus w. So add the i's together. So 2 plus 3i. And then plus 3 minus 4j plus -2 plus 5k. 2 plus 3 is 5. 3 minus 4 is -1. And then -2 plus 5 is 3. Now we're going to do v minus w. So subtracting. So 2 minus 3i plus 3 minus -4j plus -2 minus 5k. And that will give us -I plus 7j minus 7k. Then C, we're doing 3 times v. So 3 times 2i plus 2 times 3j plus 3 times negative 2k and that is 6i plus 6j and then minus 6k. And it looks like I misplaced this 2 here. It's supposed to be a 3. So this j is supposed to be a 9. Alright, next we have 2v minus 3w. So we'll do 2v first. So vector v. So 2 times 2i plus 2 times 3j minus or plus 2 times negative 2k, and we get that this equals 4i plus 6j minus 4k, and then 3w would be 3 times 3i plus 3 times negative 4j plus 3 times 5k. So that's 9i minus 12j plus 15k. And then we're going to subtract them. So 4i plus 6j minus 4k, and then minus 9i, and remember we're like distributing that minus to each thing, so it's going to be plus 12j and then minus 15k. I'm going to combine my like terms and get negative 5i plus 18j and then minus 19k. Now we're doing the magnitude of v, and so the magnitude would be a1 squared plus b1 squared plus c1 squared. In this case, since there's 3 variables, and then a is 2, b is 3, and c is negative 2. So square root of 2 squared plus 3 squared plus negative 2 squared, which is 4 plus 9 plus 4, which equals the square root of 17. Alright. Then we have the dot product of these. So here we go. It's the A's, the I's multiplied plus the B's multiplied plus the C's. So here we're doing V times W. So 2 times 3 plus negative 3 times 3 plus 6 times negative 1. So that's 6 plus negative 9 plus negative 6. The 6 minus the 6 cross, so we end up with just negative 9. Alright, next we have here v times v. So 2 times 2 plus negative 3 times negative 3 plus 6 times 6. So that's 4 plus 9 plus 36, which is 36 plus 4 is 40, plus 9 is 49. And then we have here the magnitude of v. So the square root of 2 squared plus negative 3 squared plus 6 squared. And that is 4 plus 9 plus 36, which equals the square root of 49, which equals 7. lastly, we're going to find the angle between the vectors, and here we're trying to find the angle between u, which is 2I minus 3j plus 6k, and then v is 2I plus 5j minus k. So our first step is going to be to find what the dot product of u and v is. So let's find that. So to find the dot product, we're going to multiply them together. So 2 times 2 for the i's, plus negative 3 times 5 for the j's, and then plus 6 times negative 1 for the k's. And that gives us 4 minus 15 minus 6, which equals negative 17. Next, we're going to find the magnitude of u. So that's the square root of I squared, which is 2, plus j squared, which is negative 3, plus 6 squared, so that's 4, plus 9, plus 36, which is the square root of 49, which is 7. And then the magnitude of v would equal the square root of 2 squared plus 5 squared plus negative 1 squared, which is 4 plus 25 plus 1, which is the square root of 30. And now we're going to plug it into the formula. So cosine theta equals negative 17 over 7 square root 30. Now we're going to solve for theta by multiplying both sides by cosine inverse. We have theta equals the cosine inverse of negative 17 over 7 square root 30. So theta equals, plug it in your calculator, and we get that it equals about 116.3 degrees. And then that's it. This is more of a word problem type, so we're not going to do it. That's it. All right, let me know if you have any questions.